Welcome back, PrepStation SSCE Tutorial Physics, Lesson 3. Okay, so in Lesson 3, we are going to look at linear motion. Motion is actually a very wide topic, okay, very broad topic. We have projectile motion, we have circular motion, we have simple harmonic motion, we have linear motion, and all of that. But let's quickly look at linear motion because of the limited time. And under this, we are going to look at types of motion, causes of motion, types of force, and then the derivation of equations of motion. Okay, let's quickly start with this. Motion of an object. An object is a motion when its distance does what? Change from one point to another. Motion is simply the change in position of an object from one point to another. There are four basic. Although if you go on net, you see many, but we have just four. And out of these four, you can have other types of motion. So the first one is circular motion, also known as rotational motion. The second is oscillatory motion, also known as vibratory motion. And then the third one is translational motion. Then the last one is random motion. Okay, so we're still looking at types of motion. Circular motion is the motion of an object along a circular path. When an object moves in concentric circle about a point, we call that circular motion. Example of circular motion is satellite around the earth, fan blade, automobile tires. Anything that goes about a point in concentric circle is an example of circular motion. Then oscillatory motion has to do with repetitive motion, where you have to and fro, an object moving left, right, up, and down. For example, a simple pendulum is an example of oscillatory motion. And a vibrating tuning fork, a loaded spring, a loaded test spring, test tube, is also an example of oscillatory motion. Then we have translational motion. Now this is the motion of rigid bodies. What do I mean by that? For example, you have a passenger in a car. Okay, now at the end of the day, the motion of the car will be translated to the passenger. Why? Because while inside the car, you were not rotating, you were not oscillating, you were not jumping, you were not running. As a matter of fact, you were even seated with your seat belt, but at the end of the day, there was a change in position, which is in line with the definition of motion. So that type of motion is called translational motion. So the motion of the car has been translated to you. So it's the motion of rigid body. Now, random motion is that motion where there is no specific orientation, there is no specific direction. For example, diffusion of gas, okay? Example, dust particle in air. Example, smoke in air. Example, insecticide. You know, when you spray insecticide in your room with the intention of killing the mosquito, you never can tell where the insecticide will go to. It diffuse in every direction. That is random motion. Now, causes of motion. According to Newton's first law, which is also known as the inertial law, force is the only reason why motion occurs, and force is the only reason why motion will also stop. And that is why Newton's first law covered the two aspects. Newton's first law simply says a body will continue to be at the state of rest until force is applied, or a body will continue to be in motion, in straight line, uniform motion, until the same force is applied. But a force that is applied to make a body in motion stop can be referred to as negative force, okay? Not in numerical value, but in explanation. And that is simply frictional force. Now, according to Newton's first law of motion, it takes a force to start motion. I've explained that. Now, the study of the different types of motion exhibited by a body is called kinematics. Okay, like the types of motion I mentioned before. So to study each type of motion, we simply call that aspect kinematics. But if I'm interested in studying the forces associated with different types of motion, then you refer to that as what? Dynamics. So the study of the different forces associated with different type of motion is called dynamics. All right, now types of forces. Since we have identified force as the only cause of motion, then we need to know the types of force. Now, what is force? Force is simply an agent of change. What do I mean? Force is that which changes the state of inertia of an object. What is inertia? Resistance to move when at rest, or resistance to stop when moving. So we have two types of force. We have contact force, we have non-contact force. Contact force requires touch. For example, pull, for example, push, for example, friction, for example, tensional force. But non-contact force is also known as force field. This type don't require contact, and we have just three. Number one, we have what is called a magnetic force. Number two, we have what is called a gravitational force. And number three, we have what is called the electrostatic force. Okay, so I've explained that. Example of non-contact force, I've given that already: gravitational, electrostatic, and magnetic force. Now, let's go to derivation of the equations of motion. We actually have four basic equations for solving problems in motion. They're just four, and we can easily derive them here, because sometimes WAEC will ask you to do that. So let me quickly show you how to do that. And what I want to derive here is strictly for what? Linear accelerated motion. Now, this is the motion of an object on a straight line. The parameters for defining linear motion are just three. Number one, we have speed. Number two, velocity. Number three, acceleration. And each of these, they are related, or they are also involved with what? Time. Okay, now these parameters can be combined to derive the equation of motion below. Let's start with acceleration. Now, what is acceleration? When you say accelerate, what are you actually saying? You are simply saying increase your speed, increase your velocity. So in a very simple terms, acceleration is what? Increase in speed with time, or increase in velocity with time. So acceleration could be defined as the rate of change of velocity. How do you know that velocity has changed? When you have initial velocity and final velocity, it means velocity has changed. So this is the expression, mathematical expression for acceleration. A equals the change in velocity over time. How do you know that there's a change in velocity? When there is a final velocity and initial velocity, so we definitely know that there is acceleration. So mathematically, acceleration equals to V minus U over T, where V is called the final velocity, as in WAEC curriculum, and then U is called the initial velocity. Okay, then you have the time T. This is called the first equation of motion. How? From this expression now, if you make V the subject of the formula, you're going to get V equals to U plus AT. So this is called the first equation of motion. So how do we get the second equation of motion? Let's find out quickly. Now, distance is equal to average velocity times time. Yep. So average velocity is the algebraic sum of final plus initial divided by 2. Remember how you find average? So distance equals to final plus initial divided by 2 times time. So if we go with this expression, then mathematically we can interpret this as S represents distance. Then it's equals to V plus U. V is for final, U is for initial, divided by 2. Why are we dividing by 2? Because this is average value, okay? Then times time. So mathematically, if you make S the subject of the formula from this simple expression, you will get what is called the second equation of motion. Two more to go, and I'm going to show you how to derive it very, very easy. Now recall, what are you recalling? Recall equation 1, that V is equal to U plus AT, right? And then also recall equation 2 that we just finished deriving, that distance S equals to V plus U over 2 times T. So with these two equations now, I can maneuver these two to get equation 3 and 4. Now, how do you do that? Very simple. Just remember this. Substitute equation 1 into 2 for V. Substitute equation 1 into equation 2 for what? For V. Now, what is equation 1? V equals to U plus AT. That implies wherever I see V, I can replace it with what? U plus AT. Now jump to equation 2. Equation 2 says S equals to V. So where I have V, replace it with U plus AT. This is the initial U that was there. With this, work on this expression mathematically. Then you are going to get 2UT. Why is it 2U? U plus U is 2U. There's a T outside, open a bracket. So you have 2UT plus, then you have AT times T, that is AT squared over 2. Remember, S equals to the whole of this. So by the time you play with all of these, what will happen? 2UT divided by T will give you UT, and then AT squared divided by 2 will give you half AT squared. So this is the third equation of motion. I like using simple method to do things so that students can quickly understand. As you can see, what is the method here? Just substitute equation 1 into 2. You get equation 3. And I'm going to use this pattern also to get equation 4. But this time around, I will substitute for t. So I'm still going to substitute equation 1 into 2, just the same way I did for equation 3. Follow me? Now, to get equation 4, what will you do? Substitute the same equation 1 into equation 2, but this time for t, not for v. So that means I have to go back to equation 1 and make what? T, the subject of the formula. Let me quickly show you that. Remember, equation 1 says V equals to U plus AT. So what will happen? V minus U is equal to AT. So if you make T the subject of the formula, that will be V minus U over A. So wherever I see T, I'm going to substitute V minus U over A. That is what I've done here. Look at it. This is the original equation. So in the place of T that was outside, replace it with what? V minus U over A. By the time you play with this using method of expansion, which is one of the topic in mathematics, what will happen? Then that will be simplified further to give you 2AS equals to V squared minus U squared. Now, if you make V squared the subject of the formula, voila, you get equation 4. So these are the 4 basic equations of motion. So anything I'm going to do, so long as motion is motion related, whether simple harmonic motion, circular motion, projectile motion, I need these 4 equations to start. These 4 equations will act as a start for me to do that. Okay, in summary, these are the 4 equations of motion. Again, in case you did not get it, these are the 4 equations of motion. Number 1, 2, 3, 4. I've just shown you how to derive them. So quickly, let's go to past question. Let's see how we can apply this formula to solve problem. All right, so we have the first question taken from WAEC 2023. And it said a 100 kilogram device is pulled up an inclined plane at 30 degrees to the horizontal with a force of 1,000 Newton. That is tensional force. Is being pulled up if the coefficient of friction between the device and the surface is 0.25. Determine the total force opposing the motion. Now, all we need to do is to find out the net force. Normally, when an object is on an inclined plane, there is a component of the force of gravity that tends to pull or make the object slide down. So there is a force that tends to move this object down, and then here we have a tensional force pulling it up. So in summary, we have 3 forces acting on this object. Number 1 is the frictional force, number 2 is the component of gravity, and then number 3 is the tensional force. So in order to get this answer, we need to formulate an equation that will involve these 3. So the answer to this question is 716.5 Newton. Don't panic, I'm going to show you how to do that. So let's go to the next slide. Now that is the inclined plane. I told you there are 3 forces, 1, 2, 3. So how do we solve this? Opposing force equals to Fg sine theta plus mu Fn. Mu is called the coefficient of frictional force. Why is it opposing? Because the tensional force tends to pull the object up, but these 2 forces here are opposing the motion. So we have opposing force equals to this, all right? So what will happen? Opposing force is equal to mg sine theta plus mu mg cos theta. How do we arrive at this? This Fg is a formula that denotes force of gravity. So force of gravity, Fg, is equal to mass times acceleration due to gravity. So if I want to find the weight of an object, simply multiply the mass of the object by acceleration due to gravity. So that is how Fg changes to mg. Sin theta still remains. Now mu is there, but Fn is called normal force. Fn equals to mg cos theta. So by the time you play with this, what will happen? The total force opposing this motion is these 2. So what happened? Substitute the values. Unfortunately, do we have values? Yes, we do. So mass was 100, g is 10, acceleration due to gravity on this side of the planet is 10. Then the angle of inclination is 30. That is why we have sine 30 here. And then this equals to mu. Mu was also given as 0.25 times m, which is 100, times g, 10 cos 30. Now, what next? Use your calculator and play with all of this number, okay? Now, when you do that, you will get all of these, and then your final answer will be equals to 717 Newton. This is the raw value, although the answer from there is 716 point something. So approximately to 3 significant digits, you have 717. So the option is D. Let's quickly move. We have many more questions to handle. A ball of mass 0.8 kilogram is dropped from a height h. Just before hitting the ground, its velocity is 5.0 meters per second. Determine h. So a ball was dropped as against gravity, okay? So we are looking for the height at which the ball was dropped. Remember, I gave you 4 equations of motion, and I told you anything related to motion, just go back to that formula. So let's see. Now, what is the answer to this? Let's find out. M was given, the height was also given. Was the height given? Determine h. The height was not given. This should be velocity. That is a mistake. This one is not part of it. So velocity is 5 meters per second. So what we are looking for is h. You can see it here, question mark. Now u is initial velocity 0. So the ball was dropped from rest. Now, which equation of motion will handle this parameter? How do you know which equation of motion to use? I gave you 4. Now, this is what you should do. I like using this explanation. Now, just look at the equation of motion as farm equipment. As a farmer, when you go to the farm, you have choices of farm equipment from rake, shovel, cutlass, and all of that. But your choice of equipment depends on the nature of the work in the farm. For example, if the nature of the work requires digging, you will not go and carry cutlass. If the nature of the work requires cutting, you will not go and carry rake. So how do you determine which of the formula to use? Look at the parameter given and then find out which one aligns with the equation of motion. So based on this parameter, the equation that fits into this parameter is equation number 3. Remember, I gave you 4. So equation number 3 simply says B equals to V equals to U plus this. So all I need to do is to substitute the value into this and then make the unknown the subject of the formula. So that is it. Make H the subject of the formula. So if you make H the subject of the formula, you are going to get this. So what next? Substitute the values. Substitute the values. What next? Use your calculator to play with the values and then you get this answer. Okay, so the correct answer here is A, 1.25. Okay, fine, that's good. 1.25 as is rightly checked there. Let's move quickly. More questions to go. This is WAEC 2023. The diagram below illustrates a velocity time graph. Determine the distance between x and y. Determine the distance between x and y. You don't need to bother yourself so much on this. In velocity time graph, if it is velocity time graph, the slope of the graph represents the acceleration or deceleration of the graph, while the area under the graph represents the total distance covered. But in this case, what we are required to do is to find the distance between x and y. So we have no business with this, we have no business with this. So all I need to do is to find out what is the shape under x and y. As you can see, there are 3 shapes here. Although if you join it together, you have it as one. That is a trapezium. But because we are not required to find everything, I'll just demarcate it. So if you look at the shape between x and y, this is what? This is a rectangle. So I'm simply going to use the formula for calculating area of rectangle to find the answer to that. So use the formula for area of rectangle. Why? Because of the shape. Because of the shape. So when you do that, the formula for area of rectangle is length times breadth. So the length of this is 40. Between 40 to 8, you have 4. So the breadth is 4. So all I need to do, multiply 40 by 4, and then you have the answer as 160. Very simple question. Now let's move forward to another question. The engine of a car provides a forward force of 1240 Newton and a total resistive force. Resistive force here refers to what? Frictional force on the car is 800 Newton. If the mass of the car is 1220 kilogram, determine the distance the car has traveled. Well, what should we do? Find out the net force. How do you find the net force? Remove the opposing force, which is the frictional force. Now, the force provided by the engine is 1240 Newton, but the opposing force is 800. So what is the effective force? Effective force is what is called net force. So what do? Subtract 800 from 124 to know the effective force. So the answer to this is 22.2 meters. But then, let me show you how this was done. First, list out the parameter. What are the parameters? F up 1240, the force of the engine. The opposing force, frictional force, is 800. Now, VT is what? 8, I don't think that is part of it. Then mass of the car is this initial velocity. So the velocity here is 4 meters per second. We are looking for distance S. So what do? net force equals to F up minus this. Why are we doing this? We want to find the effective force. So subtract this to get the effective force. The effective force is 440 Newton. Now, 440 Newton. According to Newton's second law simply says that force is directly or is equal to mass times acceleration. In stating it, we say force is proportional to acceleration provided mass remains constant. So Newton's second law mathematically is F equals to ma. So net force equals to ma. From this, I can find the acceleration of this object. So the acceleration of this object is 0.36 meter. Now that I know the acceleration, how do I calculate the distance? This has to do with motion. So what do? Quickly fall back to the equation of motion. And this is coming from equation number 3. So from equation number 3, make H the subject of the formula, substitute these values. These values were given. We just calculated A. V was given, U was given. So when you substitute these values into the formula, you are going to get the final answer as 22.2 meter. All right, let's quickly move forward. More questions to go. A small object of mass 50 grams is released from a point A. Determine the velocity of the object when it reaches a point B, a vertical distance of 30 meters below. All right, these are the options, and the answer is 24.5. Don't panic. I will show you how we got 24.5. First step, list out the parameter. Second step, figure out the formula. Again, the choice of formula out of the 4 equations of motion you have depends on the parameter. Don't pick a formula that does not have the parameter. For example, let me show you what I mean. Now, this formula V is equal to U plus AT is the first equation of motion. I cannot use this formula. Why? Because T was not given. I cannot use this formula. Why? Because H is not part of the formula. So that is how you choose. Although as a physicist, I can find my way out, but to save time and save stress, always go for the formula that has all the parameter in it. So this has all the parameter, and we are looking for what? What are we looking for in this question? We are looking for V. So just continue to substitute the values. As you can see, V1 is 0. So in the place of 0, that is U, put 0. Then in the place of V2 is what we are looking for. So by the time you play with all of these, V2 will give you 24.49 approximately. You have it as 24.5 meters per second. I believe this is very sweet and simple, and I want to believe you are following me. Question number 6, a body of mass 25 kilograms moving at 3 meters per second on a rough horizontal floor is at rest while sliding through a distance of 2.5 on the floor. Calculate the coefficient of friction. All right, so what will be the answer to this? 0.18. Calculate the coefficient of friction. So let's quickly find out how do we do this. Now there is a formula for friction. Okay, there's a formula for friction. So first I'm going to find the acceleration, and then from the acceleration I can find my way out. So I use the equation of motion to find the acceleration, and then use Newton's second law to relate with the acceleration. And then from this Newton's second law, break it down to get mu, and mu represents the coefficient of friction. So from here, make mu the subject of the formula, and then your answer will come out. So that is it. So mu equals to A over G, and that will give you 1.8 divided by 10, that will give you 0.18, which was the answer we saw before now. Coefficient of friction does not have units, so there's no unit attached to it. Okay, we are getting closer. A car accelerates uniformly from rest at this. Its velocity after traveling a distance of 24 meters is this. Okay, so in this question, they gave us, the answer is 12 meters per second. So in this question, they gave us initial velocity. They also gave us the distance. So they are looking for what? Final velocity. So we have 3 parameters given now. So how do we go about this? So initial velocity is 0. Acceleration is 3 meters per second squared. Distance was given. We are looking for V, final velocity. Again, don't pick a formula that does not have the parameter. I cannot use equation 1 because in equation 1 there is t. I cannot use equation 2 because in equation 2 there is also t again. I cannot use equation 4 because there is t. So this is the only equation that will help me out because there is no t and it has all the parameter in it. So all I need to do, make v the subject of the formula. Again, if you make v the subject of the formula, your final answer will be 12 meters per second because the square root of 144 is 12 meters per second. I believe this is simple and easy to follow. And then question number 8, a car starts from rest and move with a uniform accelerated motion. Calculate the distance. All right, the answer is 6 kilometers. Let's find out. Now, what is step 1? Outline all the information given from the question. Then step 2, find out which formula will deal with this. Now you can see the formula has changed. All this while I've been using b squared equals to u squared plus 2as. But now I have a new formula. Why? Because this time around from the parameter we have time. Unlike the other ones, we have time, we have all of this. So I cannot use, now let me show you that formula we have been using since now. So with this, I cannot use b squared equals to u squared plus 2as. This will not work. Why? Because t is involved in the parameter and there is no t in this expression. Although we can still find our way out, but I will advise, don't stress yourself. Go for what will handle the problem. So s equals to ut plus half at squared. So when you substitute all the value, having it in mind that u is 0. So if u is 0, 0 times t, everything will be 0 plus half. Now a is what? 30. This is the 30. Then you have t. T is what? 20. This is the 20 squared. What next? Play with these numbers using your calculator, and then your final answer will come out as 6,000 meters. Now, 6,000 meters converted to kilometer is 6 kilometers because 1,000 meters make 1 kilometer. All right, 2 more to go. A car moves with an initial velocity of 25 and reaches a velocity of 45 in 10 seconds. What is the acceleration? This is the most simplest of all of the question because here we are asked to find acceleration. Acceleration is 2 meters per second squared. What do? List out the parameters. Step 2, get a formula. As you can see, the formula has changed again. This is equation 1, okay? Why are we using equation 1? Because we have u, we have v, we have t. So equation 1 can give me this answer without wasting time. So make a the subject of the formula from here. If you do that, substitute all the values, then your answer will come out as 2 meters per second squared. This should be square. Okay, then lastly, a car moving with a speed of 90 kilometers per hour was brought uniformly to rest by the application of brakes in 10 seconds. How far did the car travel after the brakes were applied? Okay, so what do you do? The answer is 125 meters. So what do? List out the parameters. Now look at this. It was given a 90 kilometers per hour, but the SI unit of velocity is 25 meters per second. So if you have this type of problem, before you proceed, ensure to convert kilometer per hour to meters per second. And I have a very short code for doing that. If you are converting from kilometer per hour to meters per second, all you need to do, just multiply the number by 5/18. Okay? How did I get to 5/18? It's very simple. This is 90 kilometers. So 90 kilometers per 1 hour. Now, in meters per second, 90 kilometers is the same thing as 1,000 meters. Now, 1 hour is equal to 3,600 seconds. So by the time you play with this, 20 remove 20, you are left with 10/36. Now, if you play with 10/36, now 2 in 10 will give you 5, 2 in 36 will give you 18. So instead of wasting time coming through this, just multiply the value by 5/18. That will convert automatically 90 kilometers per hour to what? 25 meters per second. So don't be surprised that this one changed to 25. I've just shown you how to do that. Now the object came to a stop. It means the final velocity of the object is 0. When an object is at rest, velocity is 0. T was given as 10 seconds. So distance, now you can see equation 4. No, equation 2 is what we are using here. Why are we using equation 2? because all the parameters are inside here. Now, let me say this again. Because of the parameter, I cannot use this equation. V2 equals to U squared plus 2AS. I cannot use this. Why? Because in this equation, there is A, but in the parameter, there is no A. So if you use this, you're going to stress yourself. And my advice is, don't stress yourself. Go for what can solve the problem easily. Substitute the value. Final velocity is 0. Initial is 25 divided by 2 times T. What is T? T is 10. What next? Use your calculator. Just punch the number, play with the numbers, and then when you do that, your final answer will come out. So, guys, with this, we have come to the end of lesson 3. Watch out for lesson 4. Thank you.